B of 42. We have 175 milliliters, 0.1 molar, right? C2H5NH2, right? Ethylamine, with 275 milliliters, or 0.2 molar, C2H5NH3Cl. Okay, well, it's going to be very similar, right, with B. It's going to be very similar with B as it was with A. It didn't work. So we have a new volume. All right, let me draw a picture here. I have 175 milliliters, 0.10 molar of C2H5NH2. And I have 275 milliliters, 0.2 molar C2H5NH3 plus. Do we care about the chloride? No. Just like in the previous example, we did not care about the sodium. Chloride does not hydrolyze in water, so it's not going to affect the pH. We are going to mix these two. All right, we're going to mix them. All right, our new total volume will be 450 milliliters. All right, 275 plus 175. Dilution M1V1 equals M2V2. M1V1 equals M2V2. So for C2H5 and H2, all right, we have 0.1 molar, 175 milliliters, all over 450 milliliters. So M2 happens to be 0.039 molar. Here for C2H5NH3 plus, we have 0.2 molar, 275 milliliters, 50. So the molarity happens to be 0.12. So we have our molarities. Now, this is very important, right? This plus right here, right? That means we added an H plus to this species. So that means this is the acid. That means this C2H5NH2, that N has a lone pair, that's a base. All right. That means we have to look up Kb. And Kb happens to be 1.8 times 10 to the minus 4. If we look that up. All right. However, we have a buffer again, except we have Kb. Our Henderson-Hasselbalch equation gives us Ka involved. I need Ka. Why? Because we're looking for an acid. Kb's have hydroxide in them. Ka's have hydronium. I need hydronium. So how do I get Ka? Well, if you remember, Ka multiplied by Kb is Kw. And since we are in chemistry land at course 25 degrees Celsius, Ka equals Kw over Kb. All right. Now, do you actually have to calculate Ka? No. All right. No. All right. We just can plug it into your equation, and your amazing calculator takes care of it. pH equals pKa plus the log of the base in this case, which would be C2H5NH2 acid, C2H5NH3 plus. So the pH equals the negative log. Ka is simply Kw, which is 1 times 10 to the negative 14 over Kb, 1.8 times 10 to the negative 4, plus the log of base 0.039 molar over 0.12 molar. So that means our pH happens to be 9.76. And there is 42.